For the first question, we have a molarity question, and it's asking what it will be if you start by dissolving 37.94 grams of potassium hydroxide in water up to 500 milliliters. So the first part has to be figuring out how many moles of potassium hydroxide you have. Potassium hydroxide's equation is KOH, and that's where we get that first for every statement. For every 56.1 grams of KOH, there are 1 mole. However, there's 37.94 grams of KOH. So what we get is 0.68 moles of KOH. Once we have the moles of KOH, which is 0.68 moles, we're trying to figure out the molarity. The molarity is equal to the ratio of moles of solute to the liters of solvent. So when we look at the volume, we have 500 milliliters. Now we have to use a different for every statement with that to figure out how many liters that is. So for every 1,000 milliliters, there are 1 liter. We, however, have 500 milliliters, so we should have 0.5 liters. Saying the molarity is a ratio of moles of solute to liters of solvent, another way of saying that is a division problem. But before we do that, let's actually write out the for every statement in a way that we can see it. So for every 0.68 moles of potassium hydroxide, there are 0.5 liters of solution. Using this concept, where it's a ratio, we figured out what the calculation for molarity is from our previous practice. So molarity is moles of solute over liters of solution, which is the same way as saying 0.68 moles of KOH over 0.5 liters. So the molarity is actually equal to 1.36. So molarity is equal to 1.36. For number 2, it's the same thing as number 1, so I just have the answer written up. Number 3, however, is a little bit different. It's asking for the number of moles in 2.5 liters of a 4.25 molar solution. So we're trying to figure out the number of moles, and the pieces of information we have are the liters and the molarity. So another way of writing out the molarity using a for every statement is to say for every 4.25 moles of H2SO4, there is 1 liter of solution. Because molarity is equal to moles over liters, if we do that, 4.25 divided by 1, we get a molarity of 4.25. So this is a 4.25 molarity. And using this information, we're trying to figure out how many moles there would be if instead of it being 1 liter, 2.5 liters. Here we're multiplying by 2.5. Now here we're using the same solution. All we're worried about is a different ratio. So we're not keeping anything constant, we're just figuring out the ratio when it goes from 1 liter to 2.5 liters. So we're just going to multiply by 2.5 there as well, and we should get 10.63 moles. And likewise, you have moles and you have liters. If you were to divide 10.63 by 2.5, you should also get 4.25 molarity. Because here we're not changing the solutions, we're not diluting the solutions, we're just trying to figure out how many moles there would be in 2.5 liters, so we're trying to figure out ratios. So the answer is 10.63 moles of H2SO4. Question 4 is a little bit different from everything else. We're actually starting to do dilutions. So it's saying what is the molarity of a solution made by diluting 500 milliliters of a 4.74 molar solution of HCl to 1,000 milliliters. So diluting should tell you that there's going to be a difference in the molarity. So in our for every statement, what we're really observing in dilutions are the molarity and the volume. So the for every statement for this would be for every 4.74 molar solution, there is 0.5 liters. Now you should convert it to liters because that is the units that we should be using for any molarity problem. If that's the first solution, we're actually diluting it to something else. So we're diluting it to 1,000 milliliters and using the for every statement for milliliters to liters, as I showed in the previous part. This is 1 liter. So this is 1 liter. Now when going from 0.5 to 1 liter, we're multiplying by 2. Now here's the only tricky part. When you have a certain molarity, which is 4.74 in 0.5 liters, if you're adding water, you're watering it down. And you're adding water at a rate of multiplying by 2. So if you're adding more water, then the concentration should be going down, which is what we showed today. When the liters go up, the molarity should go down. So if we're multiplying by 2 on the liter side, the concentration, or molarity, should be divided by 2. So the answer for this is 2.37 molarity. For the next question, it's the same exact way, and molarity is equal to 0.75. And the final question, done the same way as the last one, should be 0.5 molarity.